And by trial and error, you're supposed to repeat this calculation with another pair of numbers. Maybe you're going to try 6.5 and 2.5 and see what happens then. And if that doesn't work, try another pair of numbers. And I want to see at least 3 iterations when you hand this in. And eventually, I guess the person who said it last time wasn't here. I think she said 2 and 7 turns out to be. So how many people already got 2 and 7 as their own answer, which is the right answer? Okay. So of course you can't use 2 and 7 when you as an initial guess when you hand it in either. But 2 and 7 should be the last point. So after all is said and done, the proper boundary is 2 and 7. That's what really we were up to last time. Now it's only 10 minutes to go, but that's where really we're up to last time because I'm really doing this so slow that I'm almost going backwards. Okay, so we talked along the way why we can't make it. Can somebody briefly fill in the video and the rest of the class? Why don't we try to get it down to 4% or 1% or 0% by making these boundaries bigger and bigger and bigger? Why don't we do that? What was it? That's a good answer, but the more succinct answer is that because, by the way, I marked you, Ada. I marked you. Make sure I mark you here after class. Because you're going to mess up the beta, or you're going to commit a type 2 error, which is the opposite, which is the flip side of rejecting the H1 when the H1 is true. And we discussed last time, and your job is to write about it, that when you make the alpha error really, really small, that really maximizes the type 2 error, which in turn is the probability of a type 2 error is called beta. So in a nutshell, when alpha gets too small, you're going to make your beta, which is another kind of error probability, too large. So that was the answer along the way, which we spent, again, half an hour talking about last time. But now comes the part that I asked you to do for today, which a few people did. Pick 5 numbers. So you guys did it. What were the 5 numbers you picked? So now that we, again, after seeing this picture repeated 2 or 3 or 4 times and realizing that the final boundary is 2 and 7, now we know the boundary is 2 and 7. That's the good balanced, the most practical boundary. What were the 5 numbers that you picked?
4, 4, 5, 0, and 6.
So the sample size was, and you got 4, 4. Say again, please.
5, 0, and 6.
0, 6. Okay. Now, and what was the average? 3.8, which is pretty typical. When you did the other part of the spinner assignment where you picked many, many averages, you got 3.8 wasn't considered like a really weird number. Like, 3.8 is pretty typical. Now the question is, how do you interpret that? And the answer is, you check if 3.8 is in between the 2 and the 7. And since it is, what's the answer? Do we accept A0 or reject A0? So the answer is you accept the A0. You've just proven that the random number table is a good table. Now, that's the end of it. That's the answer. To those who didn't do the homework, that's what I want you to do, to realize that 3.8 is in between 2 and 7, and therefore the answer is to accept the A0. Except if you put down accept A0 on a test, I'd mark off at least half credit for the following couple of reasons. So now besides understanding the main answer, which is that we accept the A0, I hope you understand now why we're going to have to modify the terminology. How can you prove the average of the table is truly 4.5 when in fact you got the average of 3.8? That's the philosophical question I want to discuss right now, which is going to lead us to change the terminology. The average really was 3.8. What do you know about these millions of numbers that the average is 3.8? How can you go ahead and say the average is 4.5? You can't. So what's the best you can say? The best you can say is that we don't have any evidence that the table is not 4.5. Remember, again, we're giving the benefit of the doubt to this guy because the publisher probably published a good table. I mean, it's weird that he or she would mess it up. So 3.8 doesn't prove the average is 4.5. It's just the proper way of saying it. It doesn't, there's no evidence that it's not 4.5. I hope you realize, so it's like a double negative. Now, another way of saying, for example, someone goes through a jury trial. He's accused of murder, and the jury says, not guilty. Does that mean he's really innocent? Hopefully, but does that mean not guilty is not the same as being innocent? He may have killed the guy, but there was no evidence to convict him. So the most you can say he's not guilty, but you can't say he's innocent. Okay, I want to point that out. So, and therefore, for that reason, you're not supposed to say accept A0. You're supposed to say do not reject A0. Now, I want you to realize, practically speaking, that's the same thing. Not rejecting it means you're accepting it, because there's only 2 possibilities. But I want to point out that we say do not reject A0. So at the end of this whole process, if you got a 3.8, you're supposed to say that implies do not reject A0. Don't say on the test we accept the A0, even though practically speaking. So I take off a couple small amount of points for that, but you're supposed to say do not reject a 0. And on the test, if you simply cite, or the homework, if you say do not reject a 0, I'm going to take off some more points, because what I want you to always write down, what does this mean in practical terms? So what does it mean after all is said and done? Now, if you said do not reject a 0, if you were taking Stat 1, you'd understand what that means. But if you're not a statistics person and you said do not reject a 0, you'd have no idea what the person's talking about. So how can you change this into English? What do we actually prove in a small sentence, basically? You have to change it into a small sentence to get full credit for it. What is that sentence you'd write down? I know I probably should do this, but I don't know why I don't. I told you in the email when I got a little frustrated, I'm going to call people instead of waiting for somebody to answer, and the same 3 or 4 people always answer. I'm going to call people, but I'm looking at a lot of blank faces here, so I don't no point in embarrassing you. If you have an answer, tell me. What do we just prove by saying do not reject a 0? Yes?
That the probability equals that alpha equals 5%.
No? That's too complicated. Something practical. In other words, this is the end of a whole process. Again, you're not even, for those of you who haven't done the homework, the whole homework involves these 3 pictures repeated for 2.5 and 6.5 and a whole bunch of, the whole board would be filled up with calculations till we ended up with this final answer of 2 and 7, which in turn leads to the answer do not reject a 0. But what was the initial question? What was the question that we asked? Yes? Yeah, the question was, is it a good random number table or is it a bad random number table? So what do we just prove? As far as we're concerned, what do we prove? That's by saying we accept the A0, which is really what it boils down to, we're saying the table is a good table. So this implies that it's a good table. Now, it doesn't really mean for sure. I mean, it wouldn't be surprised if it turns out the average is really 3.8 and it's a messed up table. But giving the guy the benefit of the doubt, all the evidence so far is showing it's a good random number table. That's basically it. Yes? I'm sorry, I can't hear you. That's even smarter thing to say. That's very good. Or better yet, this is probably better to say that, given what I just said. There's no evidence. There's no evidence. I don't want to make it so formal and so complicated sounding, but that's really the right answer. There is no evidence that the random number table is bad. But if you put that on the test, it's a good random number table, I would not take any points off. But I want you to put down something that shows you understand the implication of what you're calculating here. Okay, so Brian, would you just shut it off for a second while I